Yes. In this particular video, we are going to see convolutional neural networks. And with respect to convolutional neural networks, without waiting much, I'll go into the concept. We have mobile phones in Android, iOS, and so on, and we usually take cameras in mobile phones, right? And usually the power of our mobile phones with respect to the camera will be like minimum 48 megapixel and so on, right? So what is that 48 megapixel? That represents the quality of the images that you take using that particular camera. But when we use those quality images into our deep learning algorithms, it actually affects the computation of deep learning. Why? Because they are huge. Say, for example, I take a 48 megapixel image, and this 48 megapixel image can be actually represented as 48 into 10 power 6. So that is what it actually. So say, for example, if I want to take an image, which is of size, say, some landscape image, you assume like I want to have an image at 200 across 300. Now this is going to be a landscape image where I'm going to have a height less than the width, right? So in that particular case, I'm having an image dimension, and this image dimension is nothing but the number of pixels in the image. Say, for example, if the height of the image is going to be 200 and the width is going to be 300, what is the total number of pixels inside that image is nothing but 200 into 300, which is actually 6,000, 60,000, right? So this is how we actually calculate the number of pixels. But this number of pixels is only for that image with respect to height and width. But if you take the whole image background, it is going to be in terms of megapixel. So whatever pixel comes, that should be multiplied with respect to that mega value. So we know, right, 1 kilobyte, 1 megabyte, and so on. So this megapixel represents 10 power 6. So 60,000 into 10 power 6 number of pixels are there. So what is that pixels is nothing but they represent the quality of images. Say, for example, can anyone say like how many number of colors we have? Just we have only three colors, right? Red, blue, and green. And all these three colors will form in such a way to collaborate and give many other colors in real-time world. But basically, if you see, there are only three colors. And that's how pixels are also formed. So pixels is nothing but small points in the image. Those small points will combine and becomes a image. So when those points actually reduce, it means that the quality of the image reduces. So this is how this particular image processing will come into play. So what we actually have to do is when I take a particular image and if I want to process it, say for example, I need to do uh, an image processing task for face recognition. And I take an input image which comes through camera and assume that the quality of the camera is good. This is going to be 48 megapixel. In that particular way, what I actually have to do is I cannot exactly remember the entire face each time I do face recognition. Say for example, face unlock applications in mobile phone. So what I have to do is let me take some important feature in my face that differentiates my face to other people faces. So that is what is actually I require. So what I will usually do, let me actually take important features in the image, and how we can do take important features is nothing but by using a method called as compressing the image. So what is that compression and where that comes from is nothing but the convolution. So we have something called as neural network. Hope you already know. Like neural network will have input layer, set of hidden layers and output layers. But there is a type of neural network called as convolutional neural network where instead of directly giving the input to the neural network, before the input itself, we can compress the image to give only the essential features to the image. So that is what actually we say convolutional neural network. So the very first thing what I want everyone to understand is there is a concept called as convolutional neural network where convolutional means compression. So if I compress an image, what will happen? So if I actually have an image with a huge megapixel value, and if I try to compress it, what happens? First, we'll have some background reduction. we'll get some fadeness coming. You will get some small colors going and so on. So what happens, some important portions of the image alone will be withstanded, many other portions will get removed. So that's what we say it as compression. So by compression, what happens, the features in the image which are not needed, or the pixels in the image which are not needed, will be removed one by one. And finally, the important features alone will be present, and that features are the best features to distinguish that particular image from all the other images. So this is what we call it as convolutional neural network. The process convolutional is what compression I explained. Right? Am I making it clear the concept definition for convolution?
Yes, sir.
Yes. I'll be happy if others, in addition to Magdalene, also is answering. Thanks. So assume that now initially I have an input image and I cannot directly work with say 200 plus 300 dimension. So if you see a matrix over here, so assume that this is going to be an image. And yes, Hariharan, you asked me a question. Yes.
சார் ஒரு தடவை லைக் ஷார்ட்டா என்னன்னு மட்டும் சொல்றீங்களா சார்? லைக் கன்வல்யூஷன் நியூரல் நெட்வொர்க்னா ஷார்ட்டா லைக்
Yes.
ஓவராலா ஒரு
Yes. Uh, for explanation, say Hariharan is asking me a question like, in short, what I can say about convolution. In short, in a single word, if I have to explain convolution, I can say it is compression. So what is convolution? Convolution is nothing but compress the input images. So that is what convolution definition is, compression. Then what is that neural network? Neural network, we know that they has three layers: input layer, hidden layer, and output layers. But this convolution is from a mathematical background that says before you give the input to the neural network, you reduce the number of neurons. Say, for example, we know a general neural network will have like this structure. Hope you remember. We'll have like inputs and we'll have some hidden layers and we will have some output layers. And we'll have some n number of connections going into the input layers and kind of steps. Right? So this is how we actually do with respect to the things, right? But what happens is if the number of inputs and outputs is actually high, then the complexity of the model will also increase. Am I right? Because here, if you see how many inputs are there, can you see? Can you say how many inputs are there in this particular rough neural network I have
Three,
drawn? Three.
three,
So
three.
yes. If the number of input increases, what happens? The number of arrow marks which I actually make from this particular input to the hidden layer also increases. So that is what is actually represented here. If I want to use a 200 cross 3000, 200 cross 300 image, and that too raised to the power of 10 power 6, then it takes actually 60,000 into 10 power 6 sizes of images. That many number of input circles or input neurons I have to take when I want to give it to a neural network. But my typical neural network is not capable of working on that many big inputs. So that's why what I have to do, I should compress my input. If I compress, what will happen? This 60,000 can be reduced to something called as 600. There is a process to do that, and that process I say it as convolution or compression because the pixels are reducing, and hence the word compression. Mathematically, the word is called as convolution. Hope I cleared everyone and particularly Hariharan for your wisdom, right? Yes. Now let me go into the max over here. Assume that I'm having an input image. Usually images are represented as matrices, right? If it is nothing but I'm having a 6 cross 6 image, right? I'm having a 6 cross 6 matrix. Typically, this matrix is assumed to be an image where I'm having 3 as a pixel, 2 as a pixel, 6 as a pixel, and so on. And all these pixels will represent some colors, and together they will be forming something called as an image. So this is how we actually do for. Now I'm in a situation, say assume I couldn't handle this 6 cross 6 image. If it is going to be a 6 cross 6 image, how many pixels in total?
36.
36. So assume that I don't want to use 36 input neurons to my neural network. In that particular case, what I have to do is I should reduce that 36 into a number, say from 10 or 6 or 12, whichever is supposed for me to be comfortable, so that I can reduce or compress. So that is what I'm going to do. So assume that this is going to be my input image. And this input image, I represent it as say I. Now to compress it, we have to use something called as a filter. Now, say for example, I go in a more colloquial way, like we use rice flour in our home, right? Usually, rice flour will consist of rocks or other particles, and usually our mother or some other people will use some filter, and they will put the rice flour onto the filter, and they will shake so that when stones will be on the top, all the rice powder will come down. So that is what we actually see in our homes. Similarly, here also in the input image, we can have some filter inside this image so that some portions of the image they are not needed can be deleted. So that is what we call it as a filter in convolutional neural network. Let me take a very default filter, and if you are able to capture, let me say, know like if you are able to find what kind of filter it is. I'm just putting a matrix. Can you say what type of matrix it is? It will be good.
Diagonal.
Yes, diagonal. Okay, but there is a unique name for this.
Identity, sir.
Yeah, very good. This is actually called as identity matrix, and this particular matrix will have one more feature, like it has many number of zeros. When the number of zeros is increased, it means that the computation is reduced. So that is why I used here. But it is not that all time you have to use only the identity matrix. Any matrix can be used. But the thing is, since it is going to be easily usable, so I'm just using an identity matrix. So this matrix, I call it to be either filter, or in other words, I call it to be kernel. So the size of the kernel is going to be a 3 cross 3 filter, and image size is going to be 6 cross 6. Now, in the right hand side, I'm going to use some characteristics. I'm going to have n value equal to 6. N is nothing but number of pixel dimension in original image. So it is going to be 6. And I actually use f value equal to 3. That is nothing but filter size. So these two things I actually note in the right hand side now. Now let me do convolution operation represented like this. So if you put a cross like this, it is multiplication. And after putting cross, if you put a circle over it, I call it as convolution symbol. Right? So this is how convolution is actually represented mathematically. Now let us do this problem. Right? I'm having a 3 cross 3 filter. So what I have to do is, I have to go to my matrix and select a 3 cross 3 first square. Usually convolution will happen only in square matrices, and that too even matrices. So my filter size is 3 cross 3. So in the original image also I select the first 3 cross 3 matrix. So I have selected this. Now what is the process is, multiply the entire 326 260 321 with this identity matrix. Not a matrix multiplication, a normal scalar multiplication. Means that 3 should be multiplied with 1, 2 should be multiplied with 0, 6 should be multiplied with 0, 2 should be multiplied with this 0, and so on. Right? This is how you have to do. And if you do 4, what you will actually get is, you'll be getting a number, say 3 plus, if you know the answer, you can also say 0 plus 0 plus 0 plus 6 plus 0 plus 0 plus 0 plus 1. Am I right? Are you able to understand what
Yes,
I'm actually doing? So just
yes,
pick,
yeah.
we are getting only 3, 6, 1. Others are becoming 0 because this is going to be an easiest matrix filter. So which gives answers only in the diagonal. Others also should be multiplied. Since they are 0, answers also will become 0. So this is how I actually do. And my total answer is going to be 3 plus 6, 9 plus 1, 10. So what is my answer is going to be 10. I put here 10. Now, what is the next step I do is, I go here, I select my next row. I go here, I select my next 3 matrices. Now, what is my next three matrix? I just move one step forward. So previously I was actually present in a row, which is actually 3, 2, 6, 2, 6, 0. Now I just moved one step ahead. So now what I have to do? 2 into 1, 6 into 0, 5 into 0, 6 into 0, 0 into 1, 1 into 0, likewise. Can you say like what will be the answer now? It will be like 2 plus
2 plus 0 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 plus 0.
yes. So it will be like mostly 0 because all the items are mostly 0. So the final answer will be 2. Next step we actually do was going to the next square. So my next square will be this. So what will be the answer for this?
6 plus 0 plus 0 plus 0 1 plus 1 plus 0 plus 0 plus 0 plus 5.
So the
Answer 12.
answer will be 12. Am I right?
12.
6 plus 1 plus 5. 6 plus 1 plus 5. 7 plus 5, 12. 6 into 1, 1 into 1, 5 into 1. All other items will be 0. So our total answer will be 12. Is it fine?
Yes, sir.
Yes. So the final square was this. There is one more square left out that to be covered. So this will be the final
16.
square. So I'll be taking 5 plus 5, 10 plus 6, 16. So this is what we complete the first row. So let me say the next row, then it will be easy for you to capture what is the difference. So next row, I go one step down now. First, what I did is one step right is a movement. Now one step down, I'll be going. So this is what the movement now. I'll be going this way. So what will be the next one? 2
6,
plus 2 plus 4, 2, 6.
6.
Subsequently,
11,
this will be the next square and so on. So can you say the answers finally? So
13.
this will be 6. Up next,
11,
11.
2,
I'm just to say writing your answers. I'm not checking. Okay, 2,
7, 7,
7. Next row,
15,
3 plus 8, 11 plus 4, 15. Yes, fine. 15,
7,
7,
6,
6,
2,
2. Good. 7 plus 6 plus 6,
19,
19, 13, 7,
7, 9.
9. Good. Do you have any more thing? Because it will not go down further. So what is the final answer for me was this. So what is the dimension of this is nothing but
4 into 4.
4 into 4. Originally, I had 36 pixels. Now I have only 16 pixels. So this is how it actually goes on. But I have to mathematically prove that yes, it has been compressed and how it is being compressing and that mathematical feature is needed. Just it is saying like, okay, filter is actually moving one by one and finally it is getting. Now I'll ask you the question, right? I'm going one step forward, one step down. Down, can I call one thing called as stride, which is equal to 1 because each time you move, you actually move only one step. Like initially you had a square 3, 2, 6, 2, 6, 0, 3, 2, 1. and then you moved one step forward so that 265,601,210 came. So you should, and when you go down also, you moved only one step. So I actually have that step as actually called a stride, right? So I actually keep another parameter in the right hand side for formula, which is going to be stride, and I represent that as yes. Now let me go to the formula for convolution. The convolutional matrix C will be based on C is equal to n minus f. What is f? Is nothing but the kernel size or the filter size. So n minus f by s plus 1. Now if you substitute and see what is our n value, initially we had 6 cross 6, so n was 6, and my filter size was 3 cross 3, so f is equal to 3, and I move only one step each time, so my stride value is 1. So plus 1 is actually a constant. So my total answer when I use a 6 cross 6 image which a 3 cross 3 filter, I'll be getting the value as
4.
4. And
4.
that's why this
4.
answer is correct. Right? So this is how we actually get. Right? Now when you understand like how it actually moves on, how we can get a compression result.
Yes,
Yes,
sir.
sir.
Yes. Now if I give you any particular matrix and the filter size, can you do compression?
Yes.
Yes, right. Now, say for example, I'm going to an additional point. What is that additional point is, if I actually use a particular filter or a kernel and it goes on, only this particular feature will actually hold on. The C is equal to n minus f by s plus 1. But there is one additional feature requirement. Why? Because this convolution is mathematically based only on matrices, matrix dimension. Say for example, I'm moving out of my house and I'm seeing a peacock. Usually peacock will be very big when it was seen live. And I'm going to a book and I'm seeing a peacock, which is what very small. Now I'm giving it to a convolutional neural network and asking my CNN to understand the features of original live peacock and the peacock in the book. Now, what my convolution will do is it will identify that that has a different image and the book peacock has a different image. Why? Because it says that is big peacock and this is small peacock. But original intention for a robotic or an artificial intelligent agent is to identify that both are actually peacocks, irrespective of the size. But convolution has a drawback that it refers only to the size of the image, and if the size is changing, then it will not accept. So this is what the basic definition of convolution. So in order to make it size invariant, even though the size is increased or below, if the feature is there, I have to say that it is peacock. I should not say that this is small, so it is not peacock, like not like that. So I should say it correctly when even small thing is actually present. In order to do that, in order to make my convolutional neural network size invariant, in order to make convoluted images size invariant. What is that invariant is? Even though the size is changing, feature should not change. Invariant. We use a feature called as, we use a technique, we use a technique called as pooling. We use a technique called as pooling. And there are two types of pooling, and those are actually called as max pooling and average pooling. So these are the two types of pooling. Now that is actually very simple. Assume that this is the convoluted image I'm having. 10, 2, 12, 16, 6, 11, 2, 7, 15, 7, 19, 13, and so on. So this is what is actually my convoluted image. Now I want to apply max pooling to this. So what I actually do is, now I split this into half. Now what is the purpose of pooling is, like in convolution you have a formula, say n minus f by s plus 1. For pooling, therefore there is a formula. What is that formula is, whatever convoluted image you give divided by 2 will be the pooled image. So if the original image is of size 4 cross 4, the pooled image will be of size 2 cross 2. But how it can be formed? Very simple. Just to take the first window. If it is 4 cross 4, we should take 2 cross 2. So this is what I'm taking a 2 cross 2 thing. Now I'm having 10, 2, 6, and 11. And over here, 12, 6, 2, and 7. And the third window is this window. And this is the fourth window. So 4 cross 4 will give you 4 windows. Now in this 10, 2, 6, and 11, what is the maximum number you can find? 11. Similarly, in this window, what is the maximum number you can find?
16.
In the third window,
19.
fourth
19.
one,
9.
9. So I'm just getting the maximum influencing pixel in the convoluted feature, and I call it that to be max pooling. If it is going to be maximum alone to be taken and reducing the image size into half, then I call it to be max pooling. In the other end, if I take 10 plus 2 plus 6 plus 11, what is the average? 12, 18, 28, 29 by 4. What is the average I'll get?
7.25.
7.25. Similarly, for the next one, 28, 30, 37, 9.25. I hope.
சார் இப்போ என்ன பண்றீங்க எனக்கு புரியல.
I'm just taking this window and taking average of those windows. Say for example, this is the third window, 15, 7, 19, and 13. So I'm just taking the average of this. 15 plus 7, 22, 32, 41, 44, 54. 54 by 4. I hope 13.75.
13.
Approximately. If I was wrong on that, it's not a problem. Then 6 plus 2, 8 plus 7, 15 plus 9, 24, which is exactly 6. Now, what is this actually called as? Again, I'm getting a half. And this is actually called as
Average.
average pooling. So what pooling does? Pooling takes only necessary features and eliminates some features which are not there. So even though the size of the image is big or small, if this one pixel is present, then I can say that they are actually the particular image. If this one particular pixel is there, I could say that is a peacock. If this is there, I could say that is a parrot. Likewise, I do not want the entire dimension to be present. Only if the small dimension is there also, I can say that is a peacock, flower, and so on. Right? So what happens? Size doesn't matter when we use pooling concept. Right? Now, am I making it very clear about how convolutional neural network problem is done in the basic? We will get an image, we will get a kernel, and based on the kernel only, image will be filtered. And when I filter the image, the dimension of the image will get reduced. And the formula for that is C is equal to n minus f by s plus 1, right? And in order to make it size invariant, I can make use of technique called as pooling. And those are two types of pooling. One is max pooling and other is average pooling, right? And this convolutional neural network can be used in several ways. Like periodically, I can put one convolution on pooling, one convolution on pooling, and repeatedly when I do convolution, the size of the image will decrease and so on it goes. One more thing what I can easily do is I can change this stride equal to 2 also sometime, where initially if I make say a particular value, and in that particular case, if I was actually want to have a scheme where the input image is going to be this square alone. Say for example, I take this last one. If this is a square, and if I was using stride equal to 1, it will directly go to the next one. Am I right? And if I string stride equal to 2, it will go to here directly. 2 times jump. If I was saying stride equal to 3, directly to here. 3 times jump. This is 1 time, 2 time, and 3 time jumps. And when I was going stride equal to 2, first I will take here. I mean the first from first only we have to take. And like second time I'll be going over here this way. So while going down also, we will be getting 2 times stride. So we can also increase the stride so that the compression will be even more faster also. Right? Am I making it clear, Pa?
Yes, sir.
Yes. So
Okay.
now we have gone into a class on both convolution, cooling, and striding filters, and so on. So on the whole, let me conclude on this convolutional neural network, and hope it is actually understandable also for everyone.